So now, what's one example of projectile motion? Well, one example, one actually somewhat interesting one, is determining the acceleration in video games. You can actually, through projectile motion, determine how fast the character falls at. So if we watch this video, we know his change in X. Well, with that, we can figure out pretty much everything about that scenario right there. So if we pull up this photo, all right, we know. Let's see now. All right. So if we make our table, we know the time, and I actually timed it. The time is 1.23 seconds. His change in X is approximately 5 meters. That's about the length of one of these boards right here. Change in Y is 25 meters, because he is 1, 2, 3, 4, 5 stacks up. His acceleration in the X direction is 0, because there's no air resistance. His acceleration in the Y we don't know yet, so I'm just going to leave that with a question mark. His initial velocity in the X direction we don't know, but we do know that it's equal to his final velocity in the X direction, because there's no acceleration. That is how you tell in the X direction. You always got to remember. Most problems won't give you this. You just got to remember that that's what it is. Unless they specifically mention air resistance, and they won't. Then we have the V0 in the Y direction and the V final in the Y direction. Now we know the V0 in the Y direction because he's not moving up or down at the start. He's just moving in the X direction. So the initial velocity in the Y direction is 0. Then we just don't know the final velocity. And we can get that once we get the acceleration. So yeah, that's how you can tell pretty much everything from that. So now Mr. Scavart has a worksheet that he should have passed out, and you can go ahead and try and solve this problem.